Well, there's our very well drained crystals. Some nice looking crystals of potassium nitrate there. Well, hello scrappers, Mike here. Welcome back to my channel. What are we doing today? Well, we're making potassium nitrate again. Yes, again. It's not deja vu. If you've seen my previous video on this, I'm doing it again. And if you saw that previous video, then you probably don't need to watch this one because it's not going to be that much different. It's just that YouTube, in its infinite wisdom, has decided to at least partially restrict the last video I did on making potassium nitrate. And who knows, they may ban it outright eventually. But who knows? But I think that potassium nitrate is an incredibly important compound for gold refiners, not just for the chemistry that I'm doing here in the beakers, but also when you're smelting. It comes in really, really handy as an oxidizer for smelting. It's pretty much a must-have, okay? If you can't get a hold of nitric acid, for instance, and I know a lot of my viewers can't, then this stuff here will make poor man's aqua regia that works darn near as well as the real thing. Yeah, this is a really important chemical. I feel that it needs to be available to the amateur refiners out there in places where they just can't buy it. So, once again, we're going to make it. And I want this to be part of my series of videos on inexpensive, easy-to-get chemicals for gold refining. So, even though potassium nitrate may not be inexpensive and easy to get where you live, I'll bet the chemicals we need to make it are. So let's get started and do this again with a few changes, and hopefully YouTube will be happy and let this video stand. Okay, let's go. All right, so here's all the chemicals you need for making potassium nitrate. And from my research, this stuff is available pretty much everywhere in the world, okay? I haven't checked every country, maybe not in your country, but as far as I know, you can get these in Canada, you can get them in Australia, you can get them in the EU, you can get them in most places. They're considered harmless, all right? So, got some potassium chloride here. This is basically a salt substitute for people who need to keep their dietary sodium low. So this is available just about anywhere. All right, and it's not all that expensive. Calcium nitrate. This is a fertilizer. Far as I can tell, available pretty much everywhere. Prilled calcium nitrate. We're going to use what's left in this green bag, same thing, from a different company, just because this bag's open. You're going to need some distilled water, and you're going to need some tap water. Okay. You're going to need a little bit of equipment too. Now, another comment I get in a lot of my videos is, that's great what you're doing, but I can't afford the glassware. I can't afford the vacuum filtration system. I can't afford this. I can't afford that in your fancy setup. My setup is not fancy, let me tell you. A lot of my equipment's home built, but still, I get that, okay? I get that. A lot of people can't afford the fancy equipment. So we're going to try to do this as low-tech as possible. Now, you will still need some glass containers that you can heat liquid in, all right? I'm going to go ahead and use my lab beakers because I've got them. But, you know, kitchenware will probably work. I would recommend using glass, though. Glass or ceramic, glazed ceramic. I wouldn't recommend using metal. You might be tempting to heat this stuff up in your wife's metal pot, but it could lead to bad issues. So stick with glass or glazed ceramic, okay, for heating this stuff up. We're going to need some other stuff too, which we'll talk about more as we get into this video. A wet-dry vacuum will be very handy. A cheap plastic Buckner funnel, if you can get a hold of one. They're a whole lot cheaper than the nice ceramic one I use for my vacuum filtration setup. So if you can get yourself a cheap plastic Buckner funnel, that would help. Coffee filters, a funnel, and you're going to need access to a freezer. And if you've got all that and all this, you can make as much potassium nitrate as you could possibly wish. All right? So let's get into it. All right, step one. We're going to start out by measuring 400 milliliters of water. Now, for this initial dissolving of the ingredients, you can use tap water. All right, doesn't matter for the first initial dissolving of the ingredients. Everything else we do, though, is going to be requiring distilled water. So we'll put the tap water away so you don't grab it by accident in the future. So 400 milliliters of water. I'm going to put this on the heat in the fume hood and get it heating up. You don't need a fume hood for this. This does not produce any noxious fumes. This whole process doesn't produce any noxious fumes. It doesn't produce anything highly toxic. So this is great. This is something you can do in your own kitchen if you want to, if your wife will let you, without worrying about poisoning your family or disturbing the neighbors with bad smells or anything. And there's no toxic waste to get rid of either. This is a pretty simple process that just about anybody anywhere can do. So let's get this on the heat and get it heated up. We need to pretty much get it up to boiling for the next step. Okay, there we are. It's on the heat, warming up. I'm going to wait till it gets to a boil, and then we'll add our other ingredients to it and move on from there. It needs to be hot, just below the boiling point, while we add our other ingredients to get them all to dissolve. All right, so otherwise they won't all dissolve. So let's go measure out our other ingredients. So we're making a relatively small batch here. And I don't even have my gloves on. That shows you how non-toxic this stuff is. I would recommend wearing gloves, though. I just forgot to put them on. But we're just going to measure out our ingredients here. We need 150 grams of our potassium chloride. And we're just making a small batch, like I said. But you can multiply this by whatever factor you want. There's 150 grams right on the money. Okay. And you can make bigger batches if you want to. Or make lots of small batches. Either way. It doesn't really matter. And then here comes our calcium nitrate. Now you'll see other people's videos on YouTube. They use either ammonium nitrate or calcium ammonium nitrate, but, well, I'm using, you can't really read it, but just plain calcium nitrate. So, you know, if you go with like ammonium nitrate from cold packs, or you get some fertilizer that's a mixture of ammonium nitrate and calcium nitrate, you will have to adjust this. And we need 200 grams of this stuff, so I need to quit jawing and pay attention as I'm pouring it out. The proportions are not super critical, but you do want to be close. So we're 2 grams over. I'm not going to worry about it. I'm not going to pull any of those krills back out of there. All right, let me close up these bags, and we will wait for the water to get hot, and then we will dissolve these chemicals in it and start our process of making some potassium nitrate. All right, our water is boiling. So I'm going to put in our potassium chloride. This is a component that's a little hard to dissolve. And I might be using a bit more water than you might see some people recommend. But I have tried using less, and sometimes not everything dissolves. And really, you got to get everything in solution for this to work right. Okay. Looks like, yeah, the potassium chloride's pretty much fully dissolved now. So let's put in the calcium nitrate. And we'll stir it until it's all fully dissolved. And this is going to take some stirring. We've got a lot of salts in this water, and there's not a lot of water there, so it's going to take a while for this to all dissolve. And you'll notice the color. It's not exactly crystal clear. That's the calcium nitrate. There's stuff in it that we need to filter out. So we'll do that next. Potassium chloride, the stuff I have doesn't have any sort of anti-caking agents or fillers or anything in it. Your mileage may vary depending on where you're buying it. And your calcium nitrate probably will not be the cleanest stuff on earth because it's meant to be a fertilizer. It's not made to, like human consumption specifications like the potassium chloride is. Okay, let's give this stuff a quick filter. Alright, we're just going to use some cheap, generic, unbleached coffee filters, and I've got just a little sieve here that fits over the top of this beaker, so that's perfect for filtration. Use whatever you've got around your kitchen, alright? Again, this stuff's pretty harmless. Wash it good, and you're good to go. I'm going to put leather gloves on over my rubber gloves. I'm going to grab that hot beaker and pour the contents through here. Through the coffee filter. Just want to get rid of as much of this crud as we can. I'm not sure what it is, but we don't want it in our finished product. So we'll just filter this. And see, it's coming through a whole lot cleaner down there. See the comparison? So a lot of this stuff's just staying in the coffee filter. I'm also going to show you how to recrystallize this stuff a couple of times. You'll wind up with really, really pure potassium nitrate in the end. Because, well, we mixed together potassium chloride and calcium nitrate, okay? So we had potassium, chloride, calcium, and nitrate ions in this liquid. All right, so we've got those two different chemicals give us 4 different species of ions in this liquid. We're going to take advantage of the fact that out of all the chemicals you could make from those 4 different species of ions, that potassium nitrate is the least soluble in cold water of any of them. So, but we're going to be left with a lot of calcium chloride in solution, which is the most soluble of all the chemicals that we could make out of this stuff now. And it also happens to be hygroscopic. It's going to attract moisture out of the air. So your crystals are going to stay wet if we don't get rid of all that calcium chloride. So we're going to recrystallize these a couple of times. And I'm just talking here to fill a little time so you know what's coming up, because we got to finish this filtration. But we're going to recrystallize these a couple of times and wash the crystals between recrystallizations to try and get as much of the calcium chloride out of these things as we can. And we need to do that if you want to make good potassium nitrate. If you're making nitric acid with it, which we will do a couple of videos down the way, you don't want to introduce a lot of moisture into your reactor where you're making the nitric acid. So we want to keep these crystals dry as possible. This is draining through nicely. The filter's pretty plugged, so it's slowing down, but we've got most of the liquid through. So I'm just going to let it continue to drip, and then we'll stash it somewhere until it cools down. And then we'll stick it in the freezer. All right, the filtration's pretty much done. I think we've got everything through that's going to come through. We've caught a lot of nastiness on the coffee filter in there. Not all of it, unfortunately. As you can see, the liquid is slightly yellow and slightly cloudy. But it's certainly a lot cleaner than what we started with. So this is cooling down. Still very hot, close to boiling, but it's cooling down quickly. Probably even before this gets to room temperature, we'll start seeing crystals grow. But I'm going to let this cool down to around room temperature, and then I'm going to put it in my refrigerator, my lab refrigerator. Now, I said we needed a freezer, and we do. But first I'm going to put it in the fridge and cool it down. And then I'm only going to put it in our freezer for a little while, because our freezer gets really, really cold. Too cold, really, for this. It'll freeze out the remaining salty water in there, and we don't want that. So I'll get it cold in the fridge and then just pop it in the freezer for an hour or two to make sure we crystallize out as much of the potassium nitrate as we can. And then we'll move on from there. But your home freezer is probably not going to get as cold as our super freezer on steroids is. So you're probably fine to just pop it in your own freezer for a little while. But I would still let it come down to room temperature first. Otherwise, you're going to have to defrost your freezer because all of the moisture that's coming out of here as steam right now is going to condense all over the inside of your freezer. So let it cool down first. All right, this stuff has cooled down to room temperature. And we're starting to get some crystal growth. There's a long one growing over there. See that? Haven't even put it in the fridge yet. There's another fairly long one right there. They're growing fast. So let me get this in the fridge. And I'll leave it in the fridge overnight. And then tomorrow, we'll pop it in the freezer for a bit. And then harvest our first batch of crystals. Well, it's the next morning, and here's our crop of crystals so far. But I think we can do better. So I just pulled this out of my lab fridge. Let me take it over and put it in our Uber freezer for an hour or so. And I think we'll see a lot more crystals develop. Okay, here is one frosty beaker after being in the freezer for about an hour. And we definitely have some more crystal growth on the bottom. All right, let me dump off this liquid. And I'll show you what I do with that. I want to drain as much of this liquid off of these crystals as I can. So I'll show you how I do that. So yeah, just set up something you can use to hold the beaker up and let it drain into another beaker. We want to get as much of the liquid off of these crystals as we can. So I'm just going to let this sit here and drain. I don't know, 10-15 minutes while I do some other stuff. I actually left this in the freezer a little longer than I intended, so there might be some ice crystals in there. So we'll just let this sit here and warm up and drain, and we'll drain off all this liquid. This liquid is a waste product. It should be harmless to just dump down the drain. Probably a little salty with calcium chloride, but you know, calcium chloride is what they put on the roads when the weather's icy, so it's pretty non-toxic. You should be able to put it down your drain. And then we'll move on to trying to clean up these crystals a little bit and recrystallizing them. So let's be back when this is done draining. Well, there's our very well drained crystals. Some nice looking crystals of potassium nitrate there, but they are still contaminated with calcium chloride and some of that yellow stuff, whatever it was. So we need to clean these up a little bit. And there's a couple of different stages to cleaning it up. And I'll show you how we're going to do it here. Okay, so we need a couple of things here. We need some very cold distilled water, which I have in this squirt bottle over here. As you can see, it's got condensation on it. It's very cold, just below freezing. And then we need a vacuum cleaner, a wet-dry vacuum, which I told you about earlier in the video. We need a wet-dry vacuum. This is just a cheap bucket vacuum, okay? And I have 3D printed an adapter that this cheap plastic Buckner funnel goes into. All right, and I will put a link to where I got this plastic Buckner funnel. Just a few bucks. They're really cheap. They're not like my nice ceramic expensive one, which costs a fortune, and I cringe every time I chip or crack one of those. But no, this is just a cheap plastic Buckner funnel, available on Amazon or AliExpress. We're going to put this back in here, okay? And what I'm going to do is I'm going to scrape these crystals that we just made out of this beaker and into the Buckner funnel. Oh, I do hope I'm on camera. I didn't check. Yes, we're on camera. Okay. We're going to scrape them into here. Scrape as many of them out of here as I can into the Buckner funnel. I'm going to sort of spread them out into more or less even layer in the funnel. And this might be a good time to turn down the sound on your phone or computer, because it's going to get a little loud. But I will probably mute the sound on this and narrate over it. have let this run for a couple minutes. The crystals are pretty dry. The vacuum has pulled the vast majority of the moisture out of them. Now, I recommend getting a very clean bucket for your bucket vac, if you use a bucket vac, or cleaning out the barrel of your regular vacuum good. Now, not this first liquid. This first liquid you need to discard. But from now on, any of the liquid that comes off of the crystals when we recrystallize them, we can recycle it back into the beginning when we make our next batch, because we've got rid of most of the calcium chloride in here. As we continue recrystallizing this stuff, these get purer and purer. There's fewer impurities, and we want to capture the little bit of potassium nitrate that does not crystallize out on each recrystallizing, and we'll just feed that back into the beginning of the process to improve our yield over time. Okay? But this first liquid in the vacuum, discard it. After that, keep your bucket clean, capture the liquid that comes off, also capture, this stuff I'm going to dispose of because this is the first liquid from crystallization. But in the future, as you capture the liquid you drain off of your crystals, save that and use it for your next batch, okay? And you can see how yellow this is. Yeah, we're going to get rid of this. It's got a lot of calcium chloride in it, and it's got whatever that yellow contaminant was in it. So we're going to get rid of that. But in the future, when we drain our crystals, we're going to save that liquid because it's good stuff. Okay. On to the next step, recrystallization. All right, recrystallization is going to make these crystals a whole lot better for pretty much anything you want to do with them. But we're going to go ahead and go through the recrystallization cycles, and I'll show you how to do it, okay? So we're going to redissolve this in water again, distilled water this time, no more tap water. And we're going to use a little less water than we used in the beginning, about 350 milliliters of distilled water. And we're going to put that in here. And we're going to put this on the heat and get those crystals to dissolve. It's probably going to take some heat to get them to dissolve in this little bit of liquid. So let me get it back in the fume hood, or you put it on your stove. I just happen to have a fume hood, and we'll get this cooking. So there we are on the fume hood on the hot plate. We turn the heat on. Heat this up. I've covered it just to keep crud from getting in. We want to keep our crystals clean. And we're just going to wait for this to heat up and see if we can get all those crystals back into solution. All right, this is warmed up enough. All the crystals have gone into solution again. So I'm going to take this off the heat and let it cool down, and then pop it in the fridge and let the crystals grow, and then pop it in the freezer briefly, just like last time. So we're going to do all that again, okay? All right, draining again. Now remember, this time and every other time you recrystallize, you can save this liquid you're draining off and use it for starting your next batch, okay? You can recover the little bit of potassium nitrate that comes off when you recrystallize each time. So keep that in mind. Once this is done dripping, it's back over to the vacuum cleaner. And it's a case of wash, rinse, repeat. Okay, the crystals have gone back into solution, so I'm going to let this cool down to ambient, pop it in the fridge, then pop it in the freezer, and then we'll clean up the crystals again. Draining again, and keeping the liquid again. Okay, now that we've got our precious, multiply recrystallized, dried out on the vacuum cleaner potassium nitrate crystals, we're done, right? Well, not exactly. Not exactly. I mean, these are dried out, but they're not nearly as dry as they could be or really need to be for most applications, okay? We're going to dry them out a lot more. We're going to keep our powder dry here. So we need a few things to do this. We need a bucket, 5-gallon, 20-liter, whatever you want to call it, with a tight-fitting lid, a smaller bucket that will fit inside this one, some sort of open-top tray where we can spread our crystals out into a thin layer so they're not bunched up too much, too thick, and we need a couple pieces of wood. And we need a damp rid refill. It might be called something else in your country, and there might be generic versions of this, but basically what this is calcium chloride. Yes, it's ironic that we're going to use the chemical that we've been trying so hard to get out of our crystals here as a method of drying them out, because this stuff is hygroscopic. This will attract moisture from just about anything else. So we're going to use it to attract the moisture out of this stuff, okay? So the way this is going to work is we're going to dump our damp rid refill, all this calcium chloride, we're going to dump it into this smaller bucket, just like that. We're going to build ourselves a desiccating chamber. Let me move the camera and show you how this is going to work. Okay, so here's our big bucket. We're going to slide this smaller bucket right inside it. It's got all that calcium chloride desiccant in it. A couple of pieces of wood, like so. That on there like so. Now we put the lid on. It's got to be a tight fitting lid. We got to keep the ambient moisture out. Okay? The humidity in the air. We don't want that in there. Okay? And we're just going to leave that. We're going to leave that for a few days. And this will do a wonderful job of drying out those potassium nitrate crystals. So we'll be back when it's done. Now, our home-built desiccating chamber here is going to get our crystals really, really dry, okay? But there still could be traces of calcium chloride on them that will make them get damp again if they're exposed to the air, because calcium chloride is very hygroscopic. So there's a couple ways you can fix this if you need your crystals really, really clean and pure. You can keep recrystallizing it and just, accepting the 10% or so loss you get each time until you get super clean, pure potassium nitrate crystals. You can even filter the liquid each time before recrystallizing. Another thing you could do is you could rinse your crystals with, I'm using, very cold distilled water to rinse the crystals after recrystallizing. Something you could do is you could use an ethanol wash, denatured ethanol. That will dissolve the calcium chloride out really nicely, and it will evaporate really quickly, leaving the crystals very dry. Now, I would not recommend doing that with the bucket vacuum that I've been showing you, because I don't know that that motor is sealed, and you probably don't want ethanol fumes going through it. Otherwise, there could be an explosion. You might need a more proper laboratory vacuum filtration setup if you're going to use an ethanol wash. But if you need crystals that pure, well, you're probably doing it for some sort of laboratory purposes anyway. So you've probably got all the equipment. Anyway, there's that. So we'll just leave the stuff in here for a couple days, and we'll check on it and see how it looks. All right, the stuff's been in our makeshift desiccating chamber for 3 days. It probably didn't need to stay in this long, but I got busy with some other stuff. Let's have a look at it. Oh yeah, I can tell this is a lot drier than when it went in. First off, it's chunky. It's kind of agglomerated together because the moisture between the crystals was removed and the crystals kind of grew together. So this is actually super dry right now. So let me get this this bottled up in something airtight before this horrible Florida humidity makes it all wet again. So once you've got your potassium nitrate crystals good and dried out, store them in an airtight container and label it so you know what it is in the future. Okay? So that was pretty easy, wasn't it? So I guess the only question that remains at this point is, does it work? Is it good potassium nitrate? Is it going to do what you need it to do? Is it going to make good aqua regia for you, or whatever else you're going to use it? Well, let's test it out. Let's give it a try and see. All right, let's see if our homemade potassium nitrate here works for its intended purpose and can dissolve some gold for us. Can we make good poor man's aqua regia with it? Well, let's find out. Let's start out with a little bit of muriatic acid in the beaker, and we'll see if we can dissolve this little bit of gold we've got in here. About a gram, not a lot. Not going to take a lot of acid. That's probably more than necessary right there. Now you'll notice I have switched to working in the fume hood. That's because we are now working with stuff that makes nasty fumes. The hydrochloric acid being one, or muriatic acid, whichever you want to call it. And once I put this stuff in, we're going to start making some nitrogen dioxide, I do believe. I'm going to put a little heat to this, not too much. I just want to warm it up a little bit. All chemical reactions tend to work a little better when they're warm. So let's put a little bit of our homemade potassium nitrate in here. A little bit, that's probably about enough right there, I would imagine, for this little bit of gold. And we'll let that warm up and see if we start getting a reaction. It's a little chilly today, so everything's good and cold, but I imagine the reaction will start pretty quick. I'll give you a look at it once it happens. Well, would you look at this? It's been maybe 3 minutes, and we got some serious bubbling going on in there. Maybe not even a whole 3 minutes. This hasn't even had a chance to really warm up yet. But look, yeah, we got a good reaction going on. So I think we've got some good poor man's aqua regia here. I suspect I put enough potassium nitrate in there to dissolve that gold. If not, I can always put a little bit more in. I've got plenty here. Now, some of you may be thinking to yourselves, Mike, why didn't you just use the calcium nitrate to make your poor man's aqua regia? Well, that might actually work, okay? But you saw how dirty that calcium nitrate was. It's a fertilizer, okay, for crying out loud. It's not a nice, pure laboratory chemical like we've made here with multiple recrystallizations. Now you could try that with the calcium nitrate if you wanted to purify it. It might make halfway decent poor man's aqua regia, but there's lots of other stuff we can do with potassium nitrate that we can't do with the calcium nitrate. So we may explore some of that in future videos where we're doing smelting and other stuff. So subscribe to see those videos. Anyway, we're just going to let this stuff cook. And I'll bet, yeah, the liquid's turning nice and yellow. Look at that. Look at that. Yeah, I think this gold's going to go into solution toot sweet and show us that we've got some good poor man's aqua regia going here. Okay, so I'm just going to let it cook and see how it goes. Well, would you look at that? All our gold's in solution, and that's some good looking poor man's aqua regia there. Look at the color. That is just exactly the color of gold in solution in aqua regia, done with our homemade potassium nitrate. And I was talking about how, you can do other things with this stuff like smelting. But another thing you can do with our homemade pure and very dry here potassium nitrate is we can make nitric acid with it. And I have a couple of videos on how to do that. I'll put a link to one in the upper right. Check that out if you'd like to. Nitric acid is super useful. I mean, that little bit of gold would have just taken a couple milliliters of nitric acid and it would have been in solution in no time. And we wouldn't have had to worry about any kind of contaminants, although I don't think we really have to worry too much about it with our homemade potassium nitrate in here. Okay, there's a little bit of potassium chloride in there now, but I think that will wash away pretty easily once we filter and reprecipitate our gold. So not really a big issue. But if you want to get your gold as pure as humanly possible, there really isn't a good substitute for using nitric acid, and it's so easy to make too. So check out that link in the upper right up here. It's not hard to make. You just need a little bit of equipment, but you only have to buy the equipment once and you can use it forever. All right, so that's how you make potassium nitrate. That's what it's good for. If you guys found this video at all interesting, educational, informative, inspirational, whatever, give it a like, give it a thumbs up, and subscribe to see my future videos where we'll probably see potassium nitrate in action in other ways in the future. So I will see you in those future videos. Thanks a lot for watching this one. Bye.